Welcome to this video. Here we are going to discuss about alpha beta pruning technique. Here can we improve the search by reducing the size of the game tree to be examined. In Minimax algorithm, we have to visit all the nodes to find the solution. It's an advanced version of Minimax algorithm from Adversial search. Here we are using two parameters alpha and beta. Some of the nodes are going to be pruned. So it is called alpha beta pruning method. We can reduce the size of the game tree searching using this alpha beta pruning method. Here the pruned nodes are not going to affect the final result. So here it's an optimization technique for the Minimax algorithm. It allows us to search much faster, even go into deeper levels in the game tree. Okay, here some of the nodes are going to be ignored. It's called alpha beta pruning because of two extra parameters we are using, which is not in that Minimax algorithm. Here alpha and beta. Here it's advanced DFS method. In this, the number of nodes evaluated in the Minimax algorithm in the game tree is reduced. The rules are, here we have two players, assume max and min. The max is always playing for increasing the score of max, and min player is always for reducing the score of max. So here we can assume the parameter alpha for max and beta for minimum. So here the nodes are pruned when min is playing. We are going to update only the beta value. So when the condition beta is less than or equal to alpha, then that particular branch of nodes are ignored. When max is playing, then what happens? We have to go for checking this alpha is greater than or equal to beta, then the remaining nodes in that branch are pruned. So depends upon the player. Anyway, both cases we can get idea about when alpha value exceeds the beta value or equals, then we have to prune that particular branch. It's not going to affect the final result. So this is the way we are going to play this game tree using max and min players. For example, take this tree. Here we have nodes. The leaf nodes we have some scores like minus 18, 15. Then how do you start to play this using alpha beta pruning? The first thing is we are going to start to the root node for max. Then assign this level for min, max and min. So always we are giving chance for max in the root node. Then each level is going to give the next chance to min, max and min, not for that leaf node. So this way we are assigning the turn for max and min. Then we have to assign the value for alpha and beta. The alpha parameter for max. So we can take this alpha is equal to minus infinite. Then beta is equal to plus infinite. Why? Because the value whatever comes, that will be the maximum when I'm going to compare with minus infinite. We don't know about alpha and beta value initially. So the minimum value is a maximum value we are taken as alpha, and maximum value infinite is a minimum value for beta. So whatever value comes, that will be the maximum or minimum when the max or min is playing. So initially I would start with that alpha is equal to minus infinite and beta is equal to plus infinite. Then we don't know about this value of alpha and beta. So write down this values here. We'll get alpha is equal to minus infinite, beta is equal to plus infinite. Again, it's a advanced DFS method. So move towards this level. Here we don't know about alpha and beta. So assign the same value. Alpha is equal to minus infinite, beta is equal to plus infinite. Again, same for that next term. Now we have the nodes in this leaf level. So this is a chance for playing min. So the min is always updating the beta value. So what we are doing is we have to compare, take one node 18, compare with plus infinite, which is a minimum value minus 18. So this will be assigned to beta. So now beta value becomes minus 18. Now again move this side. Compare this. It's still a turn for min only. Compare these two values, which is a minimum value that will be assigned to beta. So this minus 18 will be the beta value. Now after this, move back and update alpha and beta value. See who is playing now. Max is playing. So we have to update only the alpha value. So alpha value, how do you update? Compare these two values and this alpha value. Among these three values, which is the maximum, that will be assigned to alpha. So what about the value? Here we are checking this values. It is minus 18. So it's a play for max. Okay. Now write down this value to the down because it's a DFS method. Then this alpha right as it is to this. The same value is written here. Now compare this one. First see this a turn for min. So compare 1 and beta. Okay, compare these two values. The leaf level, we are comparing only two values. The other levels, you have to compare three. So here, in each level, you have to compare the alpha and beta. When alpha exceeds or equals beta, you have to prune that particular branch. So here, it is beta is equal to infinite here. Now we have node values 1, which is minimum that will be assigned to beta. Now beta value becomes 1. Again, compare this 3 and this beta value, which is a minimum 1. So, no need to change the beta value. Now, write down this value. Now, just move upward. Now, check. It's a turn for max. Now, we have to update only the alpha. How do you update? Take this value and take these three values, which is a minimum maximum value that will be assigned. So, minus 18, minus 18, 1. 1 is a maximum value that will be assigned to alpha. Yes, we got alpha is equal to 1. Again, here we visited till this one, right? So we have to move to this parent node. Now it's a chance for min, update, beta. Still we are not any value with alpha is greater than or equal to beta. So beta pruning is not yet done. We'll check the next level whether we are getting or not. So here this is a turn for min. So we have to update this beta. We have no other values not yet assigned. So move forward, write this value as it is here. Then we got this, we are writing this value as it is. Here also we have no value, write this value as it is here. Yes. Now compare. It's a turn for min. Then compare this beta value and this 14, which is minimum. Beta is equal to 1 is a minimum. So the values remain same. Again, move this side. Here compare minus 17 and 1, which is minimum minus 17. So beta values changed with minus 17. Again, move back. Here we have to update the turn for max. So update alpha. How do you update alpha? Take this value and compare this two values. Among these three values, which is a maximum that will be assigned to alpha. Now minus infinite, minus 17. So here this alpha is minus 17. Yes. Then write this values as it is down. Then compare this 19. It's a turn for min, right? So you have to update the beta, which is the minimum value. 1 or 19. 1. So no need to change the beta value. Here you have to compare, move this side. Compare 0 and 1, which is a minimum. 0 is a minimum. So update beta with 0 value. Yes, very good. Now move back this values. Then we have to update the turn for max, right? So update only this alpha. Then among these three values, which is a maximum minus 17, minus 17, 0. 0 is a maximum value. So update alpha with 0. Yes. Now move back. Here the turn for min, update only beta. The beta which is a minimum value among these three, 1, 0, 1. So 0 is a minimum value. Now beta value is updated with 0. Yes. Now with this value, move back, minus update this, it's a turn for max, update this alpha value among these three, which is a maximum value, minus infinite, 0. 0 is a maximum, so this node is assigned with 0. Yes, right on this side, still we are not getting that alpha values equals or more than that beta, so no node is pruned it. So this side at least we are expecting. So every time we have to check whether alpha exceeds or equals beta, then prune that one. But so far we have not received that condition, so we will proceed with that. So here write on this value as it is. Again write on this value as it is. Write on this value as it is. So we'll get this. Okay. Now compare. This is the turn for min. So update beta. So this value plus infinite or 5, which is the minimum value 5. So beta will be assigned with 5. Now compare these two values. This values 5 and 10, which is the minimum value 5. So beta value will be remain same 5. Then move to the next one with this value alpha is equal to 0, beta is equal to 5. Then again just write on this one. Here you have to update. You have to update this value only max, compare this value. Now we got this alpha is equal to 5, beta is equal to infinite. It's not updated because max played. The next turn again write this value as it is. Now what happens? The 5 and infinite. Okay. Now compare. This is the value. This is the turn for min, right? So compare this infinite and minus 5, which is a minimum value. The minimum value is minus 5. Now check the pruning condition here. What happened? Alpha is greater than beta. So here this condition beta is less than or equal to alpha. Since the min is playing, we have to check only beta value. It's less than or equal to alpha. Yes, the condition is satisfied. So this node is not visited, it is ignored. Okay, after 5 we can go back to the parent node. Okay, so this is the way we are ignoring or pruning that particular node. Even if you visit this minus 8, it's not going to change the result of the problem. So no need to spend time for visiting that particular node. So this has been pruned. This is the advantage of this alpha beta pruning method. Now go back with this value. Okay, now this is a turn for max. Update this value, which is a maximum value 5. You have 5 only. So just same 5 and go back to the parent level. Then this is chance for min. Then write this value as it is. Write down. Again compare the values here. Beta is equal to 1 is assigned. Then go to this side, it is 15 and 1 you have to compare. In this the minimum value is 1, so have the same value. Go back to this node, compare. It's a turn for max, so update only the alpha 001, which is the maximum value. We have to compare 001, the maximum value is 1, so it has been assigned to alpha. Then write down this value, then compare minus 17 and this beta, which is a minimum. The minus 17 is a minimum, so it is assigned to beta. Now what happened? Alpha is 1, beta is minus 17. It's a turn for min. So we have to check the pruning condition. Beta is less than or equal to alpha. So condition is satisfied. So there's a chance of pruning. No need to visit this node because it has been pruned. Okay, now go back with this values, then compare, update this max, it's a turn for max, update alpha, and again go back, it's a turn for min, update this value of beta. Okay, then again we have to go back, the value of min is here, beta, again go back, and max is playing. Now alpha is equal to 1, alpha is equal to 1, no, we got that final solution. The score for max is 1. Then finally we got this output is alpha is equal to 1. This is the way we are finding solution for alpha beta pruning method. Thank you.